about 160 degrees Fahrenheit in the top inch of the soil. Whoops. Okay. I have another picture here, just a video here real quick, showing how we're applying the hydrogen peroxide out in front of the machine. If you look close, you can see how it's kind of interacting with the biological materials in the soil, causing that exothermic reaction. Here's some of the results from the trial. These are temperature measurements recorded in the center of the seed line. Down here at the bottom at about 110 degrees Fahrenheit is our untreated control. This is our critical temperature for controlling pathogens, 140 degrees Fahrenheit. And this line shows the critical temperature for controlling weed seeds, 150 degrees Fahrenheit. Our top treatment in this case actually happened to be steam. Applying the hydrogen peroxide was turned out to be no benefit in this particular case. This is the results 2 inches away from the seed line. And again, our untreated control is about at 110 degrees Fahrenheit. Our 140 degree line is shown here. And in this case, spraying the hydrogen peroxide on the soil surface improved soil temperatures about 10 degrees Fahrenheit. However, as you can see here, none of our treatments were effective at elevating the temperature 2 inches away from the seed line to sufficient levels. Another way of looking at this data is to plot or record the highest soil temperature that is maintained for 2 minutes. Again, here's our 140 degree threshold or critical value. And you can see here, for the most part, all 4 of our treatments were able to raise the soil temperature at the 1 and 2 inch depth above this threshold for 20 minutes. At our deeper depths of 3 and 5 inches, not so good. By and large, none of the treatments were effective. And as a comparison, in the lower right-hand corner is our untreated control. This graph shows the data from 2 inches away from the center of the seed line. Again, our threshold level. And then again, by and large, inadequate performance at all of our depth ratings. The only exception might be this data point here, which again is the steam plus hydrogen peroxide sprayed on the soil surface. Another way to look at this data is in table form. Again, here we're looking at the center of the seed line and pretty much tells the same story. At our 1 and 2 inch depths, all the treatments met our 20-minute dwell time threshold, and we did a pretty good job of meeting that threshold at the higher temperature required for controlling weeds, 150 degrees Fahrenheit. 2 inches away from the center of the seed line, none of our treatments performed adequately at the 1 inch depth. At the 2 inch depth, again, the only treatment that showed any real potential was spraying the hydrogen peroxide on the soil surface. So to kind of summarize and conclude here, we thought that for a first run prototype machine, the band steam applicator and use of hydrogen peroxide showed good promise for raising soil temperatures to sufficient levels to control soil-borne pathogens, and also with a little bit of improvement, weed seed. However, better distribution of steam is needed, particularly away from the center of the seed line. Again, we want to try and control the pests in a 4-inch wide band centered on the seed line. And then also raise the soil temperatures at deeper depths. We're thinking about 6 inches to control fusarium, get that volume of soil right around the seedling, free of fusarium pathogens, and get it off to a good start, and hopefully survive and make a harvestable head. And so so we're in the process of addressing these issues. This fall, we are going trying to optimize the machine operating parameters, and then also conduct some field trials to assess the control of fusarium wilt, lettuce drop, and also in-row weeds. So I'd like to take a minute and acknowledge our sponsors for this project, and they are the USDA NIFA Crop Protection and Pest Management Program, the Arizona Iceberg Lettuce Research Council, and also Arkema Incorporated.